Now we're going to talk about writing equations of lines. For most of these, we're going to end up writing the equation of our line in slope-intercept form because that's generally the easiest form. It gives us the best information, the slope and the y-intercept. So we're going to walk through the steps that you need to do this. The first step is going to be to find the slope if necessary. So this means if the slope isn't already given to you and you're only given 2 points, you'll need to go ahead and find the slope. Remember that the slope formula, m stands for slope, is y2 minus y1, x2 minus x1, and those values of x1, y1, x2, y2 come from 2 points on the line. So x1, comma, y1, and x2, comma, y2. Those are the points on the lines. The next step is to take the slope you found and a point, either point, it doesn't matter, and plug both of those into point-slope form. Remember that our point-slope form is y minus y1 equals m times x minus x1. And then our last step will be to solve for y so that our equation is in slope-intercept form. And remember that that slope-intercept form is y equals mx plus b. For this first example, we're going to find the equation of the line in slope-intercept form, where we know the slope of the line is -4 and we want it to pass through the point -2, 1. So in this first example, we don't need to find the slope because it's already given to us. So we move on to the second step, which is to put this into point-slope form. Remember, this point over here gives us x1 and y1. So we're going to do y minus y1, which is 1, is equal to m, which is -4, times x minus x1. So you can see we're subtracting a negative here, which means we could simplify this by saying y minus 1 is equal to -4 times x plus 2. Now we just need to go ahead and solve for y, which means first distributing this -4 to everything inside the parentheses. So y minus 1 is equal to -4x minus 8. And then all we have to do is move that 1 over to the other side, and we end up with y is equal to -4x minus 7. And here is our equation of our line in slope-intercept form. The next example is similar to the first one. In this one, we are also given the slope. Our slope is 1/2, and the point we're given is 5, 1. So remember, this gives us x1, y1. So we're going to start by putting that information into point-slope form. So y minus 1, which is y1, is equal to m times x minus x1, which is 5. Again, we need to start by clearing those parentheses, which means we have to distribute the 1/2. So y minus 1 is equal to 1/2 x. Now remember, when we are multiplying a fraction and a whole number, you can think about it as -5 over 1, and we just multiply straight across. So this gives us -5/2. So minus 5/2. Now we need to move the 1 over. We need to add it over here. But remember, in order to add those two numbers, we need to have a common denominator. So I'm going to change 1, or 1 over 1, to have a denominator of 2, just like my fraction does. So this will just be 2/2. So now we're looking at this. We're going to take -5/2, and we're going to add 2/2 to that. So y is equal to 1/2 x. And then negative 5 halves plus 2 halves is negative 3 halves. Here is our equation in slope-intercept form. In this next example, we're just given 2 points, which means we need to go ahead and find the slope first. So remember, this first point gives us x1, y1. The second point gives us x2, y2. And in order to find the slope, we're going to have to do y2 minus y1 over x2 minus x1. So we'll start by plugging those in first. So m is equal to y2, which is 7, minus y1, which is 2, over x2, which is 2, minus x1. So in the numerator, we have 7 minus 2, which is 5. In the denominator, we have 2 minus negative 3, so that becomes a plus. So 5 over 5 gets reduced down to 1. So the slope is 1. Now we can pick either of the first of the 2 points to plug in. I'm going to plug in the first one just because I already have them labeled, x1, y1. So into point slope form, y minus y1 is equal to m, which is 1, we just found that, times x minus x1. So again, we're subtracting a negative, which means we can simplify that to say y minus 2 is equal to 1 times x plus 3. Now we will distribute the 1 to clear the parentheses. Y minus 2 is equal to x plus 3. And then we'll just go ahead and we'll move that 2 over by adding it to both sides. And our equation ends up being y is equal to x plus 5. Here we are in slope-intercept form. In this next example, again, we are only given 2 points, which means we have to start by finding the slope. So this is x1, y1, and this is x2, y2. So we're going to go ahead and plug those into the slope formula. So 5 minus negative 4 over negative 3 minus 1. So in the numerator, that minus a negative becomes plus, so we have 9. And then negative 3 minus 1 is negative 4, which means our slope is negative 9/4. So we're going to use that slope in either point. Again, I'm just going to use the first one because I've already labeled it. We're going to put that into point slope form. So y minus negative 4 is equal to m, which is negative 9/4, times x minus 1. Again, we can simplify over here to make this y plus 4. And at the same time, we can go ahead and we can just distribute that fraction so we can clear the parentheses. So negative 9/4 x. Now we have a negative times a negative, so this is going to become positive 9/4. Now our last step is just to subtract 4 from both sides. Now again, we have to have a common denominator. Right now, this 4 has a denominator of 1, but we want it to have a denominator of 4, just like our fraction. So we'll multiply top and bottom by 4, so this gives us negative 16/4. So we're going to take positive 9/4 and we're going to subtract 16/4. So we'll end up with y is equal to negative 9/4 x, and again 9 minus 16 gives us negative 7/4. So our final answer here is y equals negative 9/4 x minus 7/4. Next, we're going to talk about horizontal and vertical lines. So we've talked about this before, but it's been a little while, so we'll just do a quick refresher. So first, let's start with horizontal lines. Remember, those go from left to right. which means they cross the y-axis only. So if it only crosses the y-axis, it can only have a y in the equation. So these will always be y equals something. So you can see here that I crossed the y-axis at 1, 2, 3, 4. So the equation for this one would just be y is equal to 4. Now, horizontal lines have a slope of 0. So every single horizontal line will always have a slope of 0, and it will always have an equation that just has a y. Okay, so now let's talk about vertical lines. So those go straight up and down. So this is a vertical line. You can see that it only crosses the x-axis, so it will only have an x in its equation. So you can see that I crossed the x-axis at -3, so the equation of this line would be x equals -3. Now, vertical lines always have a slope that is undefined. So if we were to pick 2 points on that line and try to plug them into the slope formula, we would get that 0 in the denominator, which means it's undefined. So let's say we were asked to find the equation of the line that has a slope of 0 and goes through the point -7, -10. So remember, if it just has a slope of 0, this is a horizontal line. And just like we talked about a second ago, horizontal lines only have a y in the equation. So that means we just need to look at this y value over here, and we know our line has to go through the y value of -10, so our equation is just y equals -10. So now let's say that we were asked to find the equation of a line that has an undefined slope but goes through the point -5, 6. So remember, if it has an undefined slope, it is a vertical line. And vertical lines always have the equation x is equal to something. So we just need to look at our point over here and look at the x value, because we know it has to go through an x value of -5. So our equation is just x is equal to -5. Last, we're going to look at a few applications of writing equations of lines. So in this example, we know that a brand new TV was purchased for $1,200. After 4 years, it's only worth $800. We want to find its depreciation equation. So we're going to have to write an equation here. Now, each of these statements gives us 2 pieces of information. It gives us how old the TV was and how much the TV was worth. So when the TV was brand new, or it was 0 years old, it was worth $1,200. That's our first piece of information. Then we know when it was 4 years old, it was worth $800. So now we have 2 ordered pairs that we can use to write an equation. Now really quickly, I want to talk about how the years is the x value, because remember, that is the independent variable. That is the thing we can't change. We can't change how old something is, but what does change here, what varies, is the amount that the TV is worth. So this gives us our 2 points, x1, y1, and x2, y2. So the first thing that we need to do is just find the slope of the line. So m is equal to 800 y2 minus 1200 y1 over x2 minus x1. So 800 minus 1200 is -400 divided by 4, which we can simplify to be -100. So what this means, our rate of change, is that the value of the TV is going down by $100 per year. That's what depreciation means. So we have our slope. The only other thing we need to do is have our y-intercept. Now normally we would put this in point slope form, but if you look, we know our y-intercept. Remember, our y-intercept has an x value of 0. So we don't have to do all that putting it in point slope form and then distributing and solving for y, because we already know the y-intercept. So our equation is y equals m, negative 100, times x plus b, which is our y-intercept, 1200. So we could plug in any year for x and find out how much the TV is worth. In our second application example, we know a furnace repair company charges customers a fixed rate plus an hourly rate, or a fixed cost plus an hourly rate. A repair that took 2 hours cost $100, and another repair that took 6 hours cost $200. What is the hourly rate? So the key word here is rate. We've talked about how slope is a rate of change. So anytime you're asked to find a rate, you are finding the slope. So again, these two pieces of information give us an ordered pair. A repair that took 2 hours cost $100, while a repair that took 6 hours cost $200. So this gives us our x1, y1, and our x2, y2. So we're going to plug both of those into our slope formula. So 200 minus 100 divided by 6 minus 2. This gives us 100 divided by 4, which is 25. So this is our hourly rate. The hourly rate is $25 per hour.